Hello students and welcome to our next lesson. So today we're going to look at reversible reactions and so on the reversible reactions, so these are changes that can be made to proceed in either direction by changing certain conditions. We have some experiments such as consider burning a piece of paper or a piece of wood or plastic. So when you burn a paper, it gets consumed and it forms the ash. It is impossible to reconvert the ash back to the state, the original state. That's back to a paper. So such reactions are known as irreversible reactions. So we have some reactions that cannot be reversed, and we have those ones that can be reversed. So these are the reversible reactions, which we are saying we can proceed in two ways. We can proceed in two ways. A good example is our ice here. So if you have your ice, if you heat your ice, then they should form liquid water. But if you change the condition here, instead of heating you cool, then you should be able to get back to the ice. So this is an example of a reversible reaction. So generally, a reversible reaction has two types of reactions. The left to the right, that's what we normally call as the forward reaction. And we have the right to left reaction. That's what we call the backward reaction. So a reversible reaction is a reaction that we can be able to combine the reactants and form the products, and we can also be in a position to get back our reactants from the products, the backward reaction. We have very many types of reversible reactions. A good example, if you consider, for instance, if you have ammonium chloride, NH, which is a solid, if we heat that solid, normally ammonium chloride is a white solid, it's normally white, then you should be able to form two gases here, that is the ammonia gas and the hydrogen chloride gas. So remember, we are heating, so our forward reaction is heating, and such kind of a reaction is known as thermal dissociation, because we are splitting the compound. We are splitting the compound by heating, through heat. That's why we are calling it the thermal dissociation. So when we heat ammonium chloride, then we form ammonia gas and the hydrogen chloride gas. If you do the opposite, if you cool the two gases, then they are going to recombine to form the ammonium chloride. Another example is the one that you did of heating hydrated copper 2 sulfate, whereby you formed the anhydrous copper sulfate plus some water. On combining the anhydrous copper sulfate with the water, you get back to your blue hydrated copper 2 sulfate. So I want us to look very briefly on the characteristic of a reversible reaction. So at the beginning of a reversible reaction, the rate of forward reaction is always faster. So if you combine your reactants, like for this case, let me use this one. So my reactant here is the ice, or I can also decide to use, let's use this one. Suppose we combine ammonia gas, NH3, plus hydrochloric gas, then to form ammonium chloride. yeah, which is a solid. So at the beginning of this reaction, of course, the rate of forward reaction is faster. And why is that? Because at the beginning of the reaction, the concentration of the reactant is higher. At zero time, we have no products. So these reactants will be combining to form the products. And the rate of the forward reaction decreases as the reaction progresses. The opposite is also true at the end, whereby all the ammonia gas and the hydrogen chloride gas will have combined to form the ammonium chloride. So the backward reaction, if the condition changes here, remember here we were cooling. In order for the forward reaction to occur, we need to cool. If the condition changes, then the backward, if we get to the ammonium chloride and the condition changes, then the ammonium chloride will start dissociating to form our two substances here. So it is possible for both forward reaction and backward reaction to occur at the same time, depending on the conditions present. And in the next lesson, we're going to look at the equilibrium of a reversible reaction, where we'll see how possible it is for both forward and backward reaction, and how those reactions occur and come into a balance. Thank you.